Okay, for today's lesson, which is 2.7, number 4, it is about word problems. Like we started into, we did mixture problems before, where you had amount 1 times %1 plus amount 2 times %2. That whole kind of mixture problem is an important type. But now it's more just generally word problems. And we've done word problems like this before. The only thing that's different is that when you're done, you're going to have an equation. Last time it would have been just like this. You might have like 4r squared plus 5r all over r or whatever. But when you were done, you just had to write this and you were done. I told you this was coming, that we would take the word problems like that and make them a little harder because you'd have to graph your answers. Okay, well that's the thing. You're just going to do the exact same thing. You're going to draw a picture, label the picture, start with the purest form of the formula. You'll work down and you'll get this thing, but you won't be able to be done by just writing out the equation. You'll have to graph it. And when you look at the graphs, a lot of times they look like this graph that I had on the board to start with, like this. And you're going to be asked to find the lowest possible answer, and that's the minimum. So you're going to have to find this low spot. But see, here's the thing. When you first graph it, the window looks like this. Do you get that when you just look inside the blue window, it doesn't look like there is a low spot? You know what I mean? Like if here, I'll graph it like it looks when it's zoomed in. Do you see how that doesn't look like it has a low spot? How do you find the lowest spot on that? Well, you can't. But as soon as you zoom out of that graph, you hit zoom out, and it ends up looking something like this. Instead of just seeing this area where it looks like it's just going to keep going down forever, when you actually back out, the answers, and one of the answers looks like this. It's kind of a crazy parabola that looks kind of like a check mark. And again, if you're zoomed in at the wrong place, it doesn't look like there is a low spot. I'll assure you, all the graphs that you have today will end up having a low spot, which you'll use second calculate minimum. You'll say, get to the left of it, get to the right of it, and then get right on top of it and hit guess, and it'll say what the lowest spot is, the minimum. All right, I'm going to walk you through one of those. To begin with, everybody start by drawing me a circle. Now inscribe a square inside your circle. And now, tell me, if the radius of the circle is r, then how long are the sides of the square in terms of r? Nope. I know it seems like it'd be a simple answer like that, but it's not. Okay, so here's my circle. Here's my inscribed square. Here's my 2 r's, and you need to go this way. Otherwise, if you try to go from this side to this side, you won't match up with the square. Get what I'm saying? It won't line up with the sides. But if you go diagonally like this and say that distance is 2r, then you can figure out how long the sides of the square are. Try to do it. Use Pythagorean theorem. A squared plus b squared equals c squared. If you don't know how long the side is, why don't you call it m or something? Give it a shot. If you can do nothing else, then grab your calculator, because we're going to be graphing something in a minute. Get your graphing calculator out if you're stuck or if you're done. You don't need that. Shut it. I'd rather have you do that on your phone. Have it out. Okay. Show me the history screen when it's done so that I know it's just you and your dad. All right, so you should have said that m squared plus m squared equals 2r squared. Okay, what just happened there? Oh, wait, I just did it wrong. I only squared the r. Get the difference? It's going to be like that. Okay, because that's Pythagorean theorem. You should that should be like easy for you. That squared plus that squared has to equal that squared. Okay, now what am I trying to figure out? I'm trying to figure out what m is, right? I don't know how to label that side, so I'm going to get the m's together first. M squared plus m squared is 2m squared, 2r squared, and then I'm going to divide by 2. M squared equals 2r squared over 2. And the last thing is, I got to get the m alone, so I got to square root it. So I go square root and square root. This should remind you that there's technically the absolute value, so it should be plus and minus, but you can't have a negative side, so we can throw out that negative. So m is equal to just the square root of 2r quantity squared. I dropped my quantity there, that's important. All over 2. Whew. That's the kind of stuff you'll have to do. But wait, there's more. You won't be able to just be done there. Now, you're going to take that, put it into the equation. What equation, you say? Well, they might ask, what is the, if the area of the circle is 40, no, that would be, hold on a second. If the area of the square is 90, what's the radius of the circle? If the area of the square is 90, what is r equal to? All right, so we've got our picture. It's been labeled. Now what we have to do is get a purest form of the formula. The purest form of this formula, area equals base times height. Or in this case, since it's a square, it's supposed to be a square, base times base. Or height times height would have been fine. All right, and now I plug stuff in from my picture. Area is 90, I know that because they gave it to me. The base, I can't say m. That's what I did all this work for. I can say that. Square root of 2r quantity squared over 2. And then that's times itself, otherwise known as b squared, right? I could times it by the exact same thing here. So 90 is equal to the square root times the square root. They cancel each other out. Very good. Now we're trying to find r. You got r alone yet? Got to get r alone. Multiplying both sides. You know what? From here, you could solve this algebraically, or what's the way that it'll always work? Graph both sides, see where they cross. Yep. Nope. It is all over 2. Right here. See how these guys both got squared, but the 2 wasn't getting squared, was it? Then the 2 came to the other side. This 2 right here went to the other side. That was not getting squared. When you multiply them together, all that happens is these 2 square roots, they're exactly the same as each other, and so the square roots come off. Here, how about this? See if you get this. What's the square root of 8 times square root of 8? It's just 8. See what happens when you have 2 things? I don't actually multiply the 8s, do I? Okay, here, I'll put it over 2. Watch. What if this was 7 over 2? 7 over 2. When I multiply them together? No, no. Nope. That's always underneath the square root. So it's like this. This 2 is inside the root. I'm positive. So just make sure that you get, do you get when I multiply these that the square root just comes off and it's just 7 over 2? So that's why those 2's do not get multiplied. And if I go back here, see how those 2's are underneath the root here? That's all inside the square root. All right, so anyway, from here, I would graph both sides and see where they cross. Everybody grab your graphing calculator. Type in 90 on the one equation. Type in 2r quantity squared over 2. Okay, so when you've graphed it, basically do you get that on your graph you have one line at 90, like this, and the other line is a parabola that's going to touch it. And let me think how this parabola looks. Its y-intercept is where x is 0, so that would be 0. So it would look something like that. And wherever the two lines cross, that's your answer. What did you get? Where did those two lines cross? What comma what? Okay, I'm going to graph it for you because apparently you're having issues with that. Okay, so I'm putting it in the calculator, and if I just go like this, divided by 2, that's going to cause a problem because the top isn't necessarily going to all be done first and then divide by 2. So I'm going to put in one more set of parentheses. Second, insert a set of parentheses right here, and then I'm going to put in one more set of parentheses. It might be. I just know that that often screws people up, so I'm going to just be on the careful side. You're right. Thank you. And then I'm going to put in, okay, second, insert a parentheses right there. So then, I'm going to hit graph. I want to see where the two lines cross. All right, now I can't really see terribly well where they're crossing, so I'm going to box it in. I'm going to zoom box. All right, now of these two answers, do you get that that one's negative and I don't want to use it because it's negative? I can't have a negative side. So then this one's my answer. So I'm going to zoom in on that one. And I'm going to go second, calculate. And I want the intersection of those two lines. And then I'm going to say enter, enter. And then I'm going to make sure that I'm to the right here by that one. There we go, good enough. Enter. There we go, 6.7. X is 6.7, Y is 90. Now, of those two, I already knew the Y. I knew the Y was 90. So I needed to know what the X was. And the X is 6.7. All right, final answer, X is 6.7. And that took a while to solve, I know. That's kind of what they're like. I'm going to give you the equation sheet in just a minute after we review a couple things from the last couple days. And then we'll just start on these word problems together. So right now, in your notes, I'd like you to try a couple more practice problems with me. First, write this one down. 1 over x plus 1 plus 3 over, let's keep it simple, 2 equals 5. Everybody, try to figure that one out. Remember what to do. Good. So tell me how to start. Act like I don't know how to do it. Tell me how to do this. Good. multiply everything by x plus 1 and 2. So I'm going to go 2x plus 1, 2x plus 1, 2x plus 1. And that's a multiply everywhere. So I'm going to multiply this. I'm going to multiply this. Okay. Cancels. 2 plus cancels. 3x plus 3 equals 5 times 2 is 10x. And then you distribute that. 10 times 1 plus 10. And then we just have to solve that down. So 3x plus 5 equals 10x plus 10. And then I'm going to get rid of the 3x. 5 equals 7x plus 10. Now I got to get this down to just x. So I'm subtracting 10. Negative 5 equals 7x. So x equals negative 5/7. Did I do that right?
Yeah.
All right. So that's just a review problem of this kind. And then the last kind is a mixture problem. The mixture problems look like this. Amount 1, percent 1, plus amount 2, percent 2, equals total amount, total percent. That's your big formula you have to know. All right, to start with, I'd like you to use this information and then try to stick the numbers in the right place and solve it. I'm going to use a situation that you can all relate to, which is grades. You get that your grades are made up of 85% tests and 15% homework. Okay, let's say I've got a kid. Pausing. All right, sorry about the interruption there. Back. So your grades are made up of 85% tests, 15% homework. All right, I'd like you to plug in this info and see if you can figure it out. The kid has a really close to an A minus. He's got an 89%. You need an 89.5 to get the A minus. Okay, if he's got an 89% going on his tests, then what does he need to get on homework to have his grade bring it up to a total of 89.5%? Stick the numbers in the right spot in that formula. See if you can do it. He's got an 89% right now in the 85% category. He does not have a score yet for his homework. Question is, what does he need on his homework so his total percent can be 89.5? That'll get him the A minus that he wants. Stick it in the formula. You can graph both sides and see where they cross to finish it if you want to. You can see how this is a real world problem. Happens to kids all the time. They want to know, like, what do I need on my final? You can actually do the calculation on it. In some cases, kids that have super strong grades going into their finals only need like a C on the final to keep their straight A. That relieves a lot of pressure. They're like, oh, I don't have to worry about it too much because I kept up such a high average. But this kid needs to get really good scores on their homework to bring their grade average up. Yes, sir?
What would be the total amount? Total percent.
Would it be like the number?
Okay. So I'll help you do it from here. All right, so here's how you get this going. First thing, if the 89% is on test, I hope you know that the 89 goes here. That makes sense? Okay. Then I don't know how much he's going to get on his homework. So what do I put there? X equals the total amount. Okay, the amount is the 89 plus the X, the 0.89 plus the X. The total percent, that should be easy. What total percent do they add up to? 100%, these two scores. 100% or 1.0. All right, now anytime you multiply by 1, you really don't have to multiply by 1, right? So if I were you at this point, I'd probably just graph both sides and see where they cross. Okay, so I'm putting in the first equation to see where they cross. And I got 0.89 times 0.85 plus 0.15x. That's the left side. Now I'm going to do the right side of the equal sign. 0.89 plus, that's in parentheses, 0.89 plus x, parentheses, times 1. Well, that doesn't need, I don't have to times it by 1, do I? All right, so I'm going to hit graph, and I'm going to hopefully see these two lines crossing. Don't see anything. So I'm going to hit zoom 6. That brings me back to a normal zoom. Let's see if I see the graphs now. Ooh, I see one line. Ooh, I see the other line. They crossed. Yay. So I can go second, calculate, intersect, number 5. And just go enter, enter, enter. It's super simple on intersecting lines. I'm having a hard time seeing exactly what I need to see here. I'm going to zoom in. I'm going to zoom box it. So I'm going to box in this area. All right. I'm going to pause for a moment here. Okay. Now, I know some people are saying to themselves, how is that even possible? That, you know, I'm getting these, some of you aren't getting the two lines to graph. That's a completely different issue. If you're getting the two lines to graph and you're saying that's not possible, maybe it's because that the kid cannot raise his grade that much by having his homework be even perfect. I still feel like there's something slightly wrong in this, so I'm going to pause for a moment and see if I can find it. Okay, I figured it out. I had set it up wrong, and I apologize. In the equation, you guys probably just listened to me and didn't think about it. What did we want for a total percentage? Do we have 89.5 anywhere in our equation? So that was a mistake. If somebody noticed it, why didn't you tell me that? All right. I'm not perfect. All right. So my total percent that I want when I'm all done is, I know this, I was thinking, oh, these add up to 100%. That made sense. It doesn't make sense. I wanted to have a percent when I'm done of 89.5. So that's 0.895%, and it would be a totally different answer. But let's not waste any more time on that. I want to start in the first couple homework problems with you. That was all review anyways. So now, here comes your worksheet. There could be even more wrong with it, but it's not worth. I've had this happen before where you end up figuring it out eventually, and then there's all hours gone by. Haven't even started your homework. It'd be way better to just punt on this thing and start your homework here. Okay. Okay, here we go. Number 1. I know these are not easy and they're not fun to, like, you know, plow through on a Friday or on a last hour of the day. Gentlemen, please stop talking. I will. All right, here we go. Number 1. Consider all rectangles with an area of 182. Let x be the length of one side of such a rectangle. All right, so right away, you got to have a rectangle, and it's got an area of 182. Everybody start by doing this. Okay, so if this side is x, then the other side, this is not that hard, but it blew last hour away, so hopefully somebody in here can come up with it. If they have to multiply to make 182, can you do it? Close. It has a 182 and an x in it. Not the 2x, no. Divided by x, I heard somebody say it. If the one side is x, the other has to be 182 divided by x. I can prove it. If you take this side and you multiply by that side, you will get 182, and that's what I want, right? If you take x times 182 over x, do you get how the x's cancel and I get 182? All right, you got to get used to that pattern because that's going to happen in like all the problems today. All right, so if they give you one side, you can know the other side is just the area divided by the x. All right, so now I've got my shape drawn and labeled. In the next part, put that aside. Thank you. The crinkly noise gets old. We're going to be taking the other side and writing a beautiful pure equation for it. What's the pure equation for an area? Area equals base times height. You could use length times width, a lot of things, but all right. Now we need to stick numbers in to our formula. Do we know the area? Huh, we do know the area. The area is, oh, is asking about perimeter? Thank you. Okay, you're right. I need to change up to perimeter now. It's perimeter as a function of x. Sorry, p. So what's the perimeter? Beautiful, pure formula. In case nobody knows it, I'm just going to say it. 2L's plus 2W's. If you don't know that already, you are expected to know that one for tests. All right. Doing number 1, you'll need a pencil. Can you do that? If you don't have one, borrow one from me. Okay. So I'm going to be trying to get my P here in terms of L and W. So I got 2 empty spot plus 2 empty spot. And now I can drop in what I know. I know the length is 182 over x. And I know the width is x. Now, this is the part where you have to graph it. And it is asking you for the least perimeter. So when you graph this thing, it's going to look kind of like this. It's a really weird graph. The part of the graph that's on the left-hand side, the part of the graph that's on the left is not possible because that's where x and y are both negative. Can you have x be negative here? No, you cannot. All right, so we throw out this part of the graph. Then of the part that's left, where do you think would be the spot that would be the least? It would be that spot right there. So once you graph this thing, zoom out far enough so you can see that it looks kind of like this. And then do second calculate the minimum. All right, so I'm going to put this into my calculator right now. Pause for a second while I do that. Okay, I hit graph and it didn't graph it at all, so I have to zoom out. I encourage you to get used to that on this unit. A lot of times you have to just keep hitting zoom out until you can see it. I can't see it yet, so I got to zoom out again. Zoom out, enter, enter. Still not out far enough. Zoom out. Enter. Enter. Aha! I finally zoomed out far enough. You see it? If you zoom out far enough, you will too. As long as you typed in the graph correctly. I'll go back to my y equals screen and make sure you know what I have on there. It's right here. 2 times 182 over x plus 2x. Notice I'm not graphing both sides and seeing where they cross. That'd be nice, but I don't know what the perimeter is. So instead, I have to just graph the one side and see where the lowest spot is. So I hit graph. Again, it looks like this. Okay, I'm going to find the low spot by going second, calculate the minimum. And then I'm going to get to the left of the spot that I want. Got to find the little spider thing. There it is. I'm to the left of the spot I want. And then I'm going to go to the right of the spot I want. And I'm going to say enter and enter. And there is the low spot. 13.49 or 53.96. Now this becomes a challenge. Which one is it? Is it X or Y? All right, if X is 13.49, let's see if that makes any sense. It's a fair final answer. If X equals 13.49, this side right there, 13.49, then would the other side possibly work? Well, the other side would have to be 182 divided by 13.49. And yeah, that would equal 182. Well, here's the weird thing. If I made x equal to 50, the other number, it would also work. So which one of those two is going to give it the least perimeter? Well, if I put in 13.49 here and I put in 182 over 13.49, actually here, I'm going to divide that for you. 182 divided by 13.49, I get 13.49. That means this side and this side are equal. 13.49, and this is 13.49, and this is 13.49, and this is 13.49. And there was another dimension that was also maybe going to work, and that was that 15 or 53. Which one has the least perimeter? This one's perimeter would be the 13.43 plus the 49 plus the 13.49 plus the 13.49. That guy's perimeter is about 53. That is the perimeter. So one of these numbers is how long the side is, and the other number is the perimeter. Let me get you that picture again. One of these numbers is how long the side is. The other one's the actual perimeter. Which one do we want? The how long the side is or the perimeter? What does the directions say? What is the least perimeter?
53.
53. That's the perimeter. It didn't ask us how long the side was. It asked us what was the least perimeter. All right, so 53.96 is your answer for that one. And that is the perimeter. And if you think about it, it's saying that y is 53. Look at my equation. Do you get how y normally goes there? So when it says y is 53, it's saying that the perimeter is 53. All right. Okay, so that is number one. I've helped you do number one. I'm willing to set up number two for you as well. I know you got 12 minutes left, and some of you would rather just screw around, but we have, this is kind of a hard assignment, and I know some people would probably like some help with number two. So I'm going to help with number two at this point. Okay, so here we go with number two. Number two, Hendricks Publishing Company wants to design a page that has a 0.75 inch. Okay, this is the part where you got to draw a picture. There's no way you're doing these without drawing a picture. So start by drawing a page. You know what a page looks like on, if you're doing Google Docs or whatever, and then they have margins around the outside of it. This rectangle here is an area of 40, so you put a 40 on the inside. And right away, you should be able to tell me if it wants one of the sides to be X, you should be able to tell me what the other side is. Not 40 minus X, you're close. 40 over X. All right. Now, next thing. If I make my margins go around the outside of it, it says specifically how wide it wants them to be. It wants the left border to be 0.75 of an inch. So from here to here, the left border, there's going to be a border all the way around it here. The left border is, how long again? 0.75. Next, the top border. The top border is 1.5 inch. From here to here, 1.5. And I wish they would have just kept that consistent all the way around, but they did not. On the right and the bottom, they are 1 inch. On the right here, it's 1 inch. And on the bottom here, it's 1 inch. Do you remember that problem that was like the rectangle that had the squares cut out of the corners? Do you remember how at the end it was always like 15 plus 2x and 18 plus 3x or whatever, or minus? This is going to be like that. All right. So for this guy's total area, not the area of the inside, the total area of the whole thing, the area is going to have to be the base times the height, right? And the base is not x. x plus, yes, x plus this distance is 1, and this distance is 0.75, so the total is x plus 1.75. So the base is x plus 1.75. The height of it is not 40 over x. It's 40 over x, but then some more. Plus that, which makes what? 2.5. So 40 over x plus 2.5. Now, guess what happens when you graph that? Well, frankly, a lot of people won't graph it right, so it won't look like anything. But just so you know, if you put this little guy in, oh, actually, you don't even have to in this case, put it in parentheses. If we'd have written it the other way, we would have. But just to be safe, any fraction you have, put it in parentheses. It's really the best to be safe on those. Then, when you graph it, it's going to be that one where when you look at it in the first place, it's going to look like there is no low spot. But if you zoom out on the graph, it looks like this, and it's got a low spot if you zoom out far enough. It looks like that. It's kind of weird. Depends on which part of the graph you're looking at, whether it looks like it has a low spot or not. But zoom out far enough, you'll see the low spot. You do second calculate the minimum, you'll be able to find the spot. And remember, when there's two answers, one of them is x, like how long the side will be. And the other one is, in this case, the area. Last time it was perimeter over here. This time it's area over here. So the y is like the area, and the x is like the side here of your shape. So when you get an answer that's an x or a y, you just have to figure out whether you want the x or the y of it. Somebody that's got the low spot, by now somebody's probably already got it. Can you tell me what it came out to be?
I got 70.
For the x?
Oh, for the y.
Okay, 70.8. And then how about the x? 5.29. So that means the side length you want is 5.29, but that's not what they asked. What they asked is what's the least area. The area is kind of like the y, which is this one. There's your least area. Yes? All right, having trouble graphing it? I'm going to stop the video at this point, and I'll help